In this lesson, we are going to continue working with exponent notation, and we're going to talk about how to say exponents when you see it. You know, what words do you use when you see an exponent? So let's review the do now answers real quickly and look over the homework, and then we'll do some additional practice after that. So go ahead and turn to your do now and make sure you have those answers correct. Go ahead and check those answers again, and if you got any of them wrong, make sure you understand where you may have gone wrong. All right, now quickly check over the homework answers once again. Here are the homework answers, and again, if you didn't get some of these correct, see if you can figure out where you went wrong. And let me know if you have any questions on these. All right, so let's go to the next page where we're going to talk about how to say exponents. Actually, we're going to do a quick review first. So just thinking about what we've already talked about, we did a little exercise yesterday about repeated addition, and we talked about how to do that in a more efficient way. So if you look at this first question, we have 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. We know that's 5, 10, 15, 20, 25, 30, 35 is what that sum is. But we also know that that's equal to 7 times 5. And the key to repeated addition is to multiply. Now, what we introduced yesterday is repeated multiplication. So in this problem, 5 times 5 times 5 times 5 is very different than 5 plus 5 plus 5 plus 5. And we learned that we can use exponents to do that multiplication. So let's see, what is 5 times 5? 5 times 5 is 25. 5 times 25 is 125. And 5 times 125, I believe, is 625. But we also learned that that is the same as 5 to the 4th power. And the key is exponents. And just to remind you that that number, the bigger number, is called the base. That's the number that you're multiplying over and over again. And the small number is the exponent. That's how many times you multiply it. That's why this is 5 to the 4th, because we multiplied 5 4 times. All right, let's talk about how we say these. Go ahead and turn to the next page, please. So let's just take a look at these bullets. First one says, a number with an exponent can be read raised to the 2nd, 3rd, 4th power, and so on. You don't always have to say the word raised, and you'll see that in the examples that we use. Also, there are a couple of special powers that have special terms. So if the exponent is a 2, you can say squared. If the exponent is a 3, you can also say cubed. So take a look at these examples. You have 4 to the 2nd power. Notice we don't use the word raised, but you can. But 4 to the 2nd power, or this is also 4 squared. 4 to the 3rd power, or 4 cubed. All right, so here's a couple practice problems. Actually, stop the video and see if you can figure these out on your own, and then come back and check your answers. All right, go ahead and check out these answers and make sure you got them correct. And if you didn't, see if you can figure out where you might have gone wrong. And once you've done that, you can turn to the next page, please. All right, here are just some more problems that I want you to practice expanding or going backwards to exponent form, and I want you to evaluate them as well. I would like you to try these without the calculator, but for some of the bigger ones you might be able to, need to use it, but I think for the most part you can do these without a calculator. So I'd like you to pause the video, fill out all the missing boxes in this table, and then come back and check to see how you did. All right, here are some of the answers, and just a couple I wanted to highlight for you. So this row was kind of interesting. It just gave you the value, and you had to figure out, some number multiplied by itself so many times gives you 36. This is a perfect square. You should get to know these. We have another one down here. So this is the same as 6 times 6, which is 6 squared. The same as 25 is 5 times 5, and that's 5 squared. So perfect squares are numbers you probably should know. Here's another one down here. 16 is 4 times 4, which is 4 squared. 9 is another one. 3 times 3, which is 3 squared. So those perfect squares are helpful to know. This one just dealt with letters, but it's the same deal. What's our base? It's the number that we're multiplying multiple times. So that's A, and we multiply it 3 times, so my exponent's 3. And let's see if there's anything else here. This is kind of a silly one. It's just 1 times itself 13 times, but 1 times 1 times 1 times 1, no matter how many times you multiply it, is always going to be equal to 1. All right. Let me know if you have any questions on any of these. Oh, I actually look at the fraction. Just a reminder, when you're multiplying fractions, you multiply the tops and you multiply the bottoms. So 2 times 2 times 2 times 2 gives you 16. All right, now you can go ahead to the next page. So here's a little application problem, and I want you to use exponents to find this answer. And I'll give you a bit of a start here. So we start off with one person, and as often is the case, sometimes people use these phone trees to try to contact a lot of people. That one person contacts 4 people. And then each of those people contact 4 people. So we have another 4, 8, 12, 16. But keep in mind, you could write this as 4 to the 1, and you could write this as 4 squared. So think about how this will play out, and what I want to know is how many people will be contacted in the 5th round. So we've done really 1 round, 2 rounds, 3 rounds, 4 rounds, and here is the 5th round. So that's the number that we're looking for. So go ahead and pause the video and try to figure out what goes in these blanks, and then come back and check your answer. All right, take a look at these answers, and really I want you to think about how each round you are multiplying by 4, because each of these people is going to tell 4, so that's going to be 4 branches off of each one of these. And what's nice about exponents is I don't have to draw all this out. I don't have to draw 4 branches off of each of these to figure this out, to count them. and then another 4 off of each of those, that would be a lot of little people here. But with exponents, I can figure this out pretty quickly. All right, so there's going to be a little problem like that on the video assessment, so make sure that you are clear on the process that I used here. All right, you can go ahead and check out the next page, please. Go ahead and complete these 3 problems. Pause the video for a little bit, and then come back and check your answers. All right, go ahead and check out these answers and make sure you're good with what they are and that you understand them. If not, you can ask me after the video. All right, go ahead to the next page and check out the video assessment. All right, here is the video assessment, similar to the problem we did earlier in the notes. So if you're watching this video in class, you have this sheet, so you can show your work on this sheet, and then note that question 2 involves your answer from question 1. The exponent notation that you use in question 1, I want you to write how you would say it in words for question 2. All right, let me know if you have any questions on any of this, and when you complete the video assessment, you can turn that in and begin the homework. Let me know if you have any questions.